Okay, so thanks everyone for coming. I'm going to talk to you about the 12-factor app, in particular as it is implemented in Node. It is not a Node-specific idea. It is a generic idea, but I'll take you through the Node specifics. A little bit about myself. I work as an independent consultant. I specialize in Node. I generally help clients build full-stack web applications. I have a website, peterlyons.com. There's an extensive blog there with lots of posts about Node. And you can go there and find this, as well as all my talks are there, including the talk that you're looking at on the screen. And I also want to invite you to ask questions during the presentation as well as afterwards. Just raise your hand, and I will repeat your question for the video. We do have a recording going, so you can review this later. So to start, what is 12-factor? And I have a photo of a platform here. And the 12-factor app is basically a methodology or a set of principles and ideas for managing the application lifecycle that came out of the platform as a service trend across the industry. And specifically, it was written primarily by the engineering team at Heroku, which was one of the earliest popular platform as a service companies. And basically, they took applications from lots of different developers and tried to deploy them in a standard way. And they had all these problems and struggles. And what they learned from that, they boiled down into these 12 factors that they publish on this website, the 12-factor app, as sort of their what they learned and what works for modern software as a service type applications. And basically all these principles are designed for the sort of current era or the platform as a service era of the internet, which includes infrastructure as a service is a thing that's available. Software as a service is a very common methodology of how businesses are being built and how software is being sold. And platform as a service is, how companies are offering this as a relatively inexpensive way of deploying your application that gives you additional value above infrastructure as a service, which would be like Amazon EC2 or DigitalOcean or something that gives you manages the hardware, gives you an operating system. The platform as a service is a higher level than that directly runs your application. And it's designed for the current set of architectures, which is scale out. So the idea is you add additional instances of your application to get better performance and capacity, as opposed to scale up, which some industries do, where they buy bigger and bigger computers to get more scale. But basically, it embodies a set of best practices and a set of opinions. So I'm going to walk you through all that, but I want you to keep in mind that this is opinions. It's best practices in a given context. These are not, absolute truths or dogma that you should just follow. And there are definitely cases where these don't apply for a given type of application in a given business sector and so forth. So this is not the only valid approach. And there are lots of industries that don't do this at all for good reason, and they're just fine. And so also the way these slides work is I'm just going to take you through these top. I'm going to say my bullet points, but if you want to come back later, you can press the down arrow and you'll get your bullet points there as well. But before we can really understand what 12-factor is, we should go back in time to prior to platform as a service, what was going on in the industry. And basically, we had a lot of sysadmin and operations type people manually SSHing into servers, running commands, and just basically doing a lot of things in a sort of manual ad hoc way, creating these things called runbooks. In the best case, you might get this thing called a runbook, which would encapsulate a bunch of tribal knowledge about this particular application at this particular company, and literally a notebook of this is what we do on the first Friday of the month, and this is what we do when this error message comes up. And it was quite extensive. And basically the idea is, each application was highly unique. Each company and their operational procedures were highly unique. And what that meant is, and all these manual procedures meant it was highly error prone, and it was also very prone to getting inconsistent state. If you have a cluster of servers that are all supposed to be consistent, and you as a human being SSH into them one at a time and try to issue the same command in the same way, your chances of getting them all consistent are actually not very good. So as you start to scale out, this approach becomes less and less viable because things just end up being inconsistent, and you get into this state where you have a few problems or a few symptoms of the problem. One of which is you have your precious golden server, which no one knows how to rebuild, and if it ever goes down and you can't recover it, your business, worst case, your business tanks and you get sued. And there are less severe versions of that where it's like, oh, there's an all weekend effort to reverse engineer what the guy did 18 months ago. So that's one problem. Another one is the scary reboot scenario where the server has been up for 10 months or so and you haven't rebooted it, and the longer it stays up, the less confident you are that if we were to actually reboot this, the application would actually come back up and function properly. And during that time, maybe you're applying security patches and you're SSHing in and editing config files, and those config files only actually get executed on system boot, and you actually made a typo, so some key service won't actually restart, but you didn't actually restart it, and then you reboot and it restarts as a consequence of that, and it doesn't come up because you made a typo in the config file. So that's kind of the state of where things are, and you end up with a relatively tight coupling between your application and the underlying operating system. And there's benefits you get from that, but primarily that's a contingency or a liability that reduces your flexibility, doesn't let you switch to a different Linux distribution or a different platform. You also end up with a high degree of variance between your dev, test, and production environments. Again, basically, that's a consequence of any kind of manual work. And that's also a big nightmare. If something works on a developer's machine, they deploy it to a test environment, QA gives it the thumbs up, and then it goes to production and breaks. That's kind of what you're trying to avoid when you have all these different tiers of deployment. And so if your process, you have all these tiers and you have a process that still creates this risk, then the process isn't really serving the goal. And then again, the same high variance across companies. So, you spend 4 years at some startup working on their infrastructure team, and then you switch jobs and none of your knowledge is relevant because they're using all highly custom scripts. It's kind of like working for Google. If you go work from Google for 8 years and then you come out into the industry, you're like, oh, I actually don't know anything because Google runs their own web server. They run their own Linux kernel. They run, all this stuff where it's custom because they're so huge and they have so many, engineers and unique problems that when you get out to the sort of meat and potatoes of the industry, which with medium-sized companies that all have the similar problems and all use open source software, then you can't share that. And that's the same thing you can get to if your stack gets way too manual, way too custom. So enter platform as a service with the idea to kind of solve some of these issues or change the dynamic and change the cost structure, change the risks around the pre-pass environment. This kind of took off, I guess, around 2008. I don't really know all the history, but that's when Google App Engine came out and was a big push for this. And of course, Heroku is sort of one of the flagship platform as a service companies. These days, there are many, many of them. Even for every programming language, there's usually a specialist one. So in Node, there's Modulus, and for whether it's Rails or whatever your stack is, there's typically one or two PaaS companies that specialize in that stack, and then there's more generic PaaS companies that are sort of agnostic about your programming environment. Or like in the case of Heroku, they start with a small offering and they gradually expand as they succeed. So at this point, Heroku supports a bunch of different stacks and can do a lot of different things. And the basic idea here is they want to get a standard workflow for what it means to deploy an application. And the basic idea is you have to get the latest source code from somewhere and create a build artifact, which gets from source code to something that you can actually execute, deploy that artifact to a set of servers, and start it up. And the sort of past trend is trying to standardize on that and say, like, look, all these people that are sort of the meat and potatoes of the industry, you guys don't have a magical unicorn build process. You should follow these guidelines, and then you can focus your energies on adding features into your application instead of spending your resources on creating custom build processes and custom deploy processes and monitoring and that kind of thing. So that sort of sets the scene, and then we're going to go through the actual 12 factors one at a time. So the first one is code base. This one is not that complicated. It basically boils down to use Git. These days in my consulting work, I rarely find companies that don't use Git or an equivalent source code management system, but I do once in a while. But if you're not using Git or something very equivalent, which is probably Git, you should use it. You should use GitHub or Bitbucket or some kind of reliable hosting for that. That's the main thing. The second thing is, if you read the 12-factor site on this, is they want a one-to-one mapping of a source code repository to an application, which basically means don't have one monster. If your company runs 6 applications, don't shove them all into one repository. And if you have one main application that is split out into a bunch of libraries, just make sure that the final application that you run is a single repository, and it references your other repository libraries using a dependency management tool, which in the case of Node is NPM. And so that's the general idea. The Node specifics here are, if you are going to create shared libraries and use them for several apps, or use them for test them independently, just extract them to a separate repository, extract them to a separate NPM package, and then have your main application depend on them just as if they were a third-party module. You can use GitHub URLs to do that, or you can use private NPM if it's if you're not able to release those as open source, or you don't want to publish them. There's still really good techniques to reference stuff within your company. So that's code base. The next one is dependencies. If you haven't seen the @funnies.js Twitter handle, I recommend it. There's a bunch of Node-specific comics up there. But this for Node is also, Node is blessed with what I consider the best package manager out there of the scripting languages. It's definitely not perfect, but I think it's far superior to all of its predecessors. And so for Node apps, number 2 basically boils down to use NPM, and in particular, use NPM properly. I talked with some folks at Heroku, and they said about 25 to 50% of the errors they see when people are trying to deploy Node apps to Heroku is not using NPM properly. And so the main idea is don't do any crazy hacks. Don't not do NPM. And as long as you do that, everything will work fine. But the basic idea here, and I have some notes. There's a few NPM config settings that are good that you may want to set. So save exact true, save true, and save prefix. This basically just prevents you from doing npm install express while you're developing, and then trying to deploy that app, and because you haven't passed -- save, your package.json doesn't know that your app actually depends on express. So when you deploy it, express will not be installed and your app will not run. This is sort of like NPM 101 type stuff, but you see people get confused or forget to stick to these practices consistently. But if you have a dependency, it goes in your package.json. In particular, you should, if you have writing an application as opposed to a shared module, you should specify the exact version of the dependency you want within it without any kind of semver, globbing, or ranging. Just put, I want Express 4.0.2, and your life will be easier. That's not true if you're writing a reusable module, but if you're writing an application that people are just supposed to install and run, use an exact version. Unfortunately, as of the current NPM, I don't think that shrink wrap actually works. But I'm told in version 3 they will make shrink wrap work and not be a pain and not be confusing. And if that turns out to be true, then you should start using the shrink wrap feature of NPM, which will lock down your entire tree of dependencies to all the versions and make sure that when you deploy it again, it'll get all the same versions. Once we get there, that'll be really good. As it is right now, we don't really have completely reproducible builds in the Node system. And then the other thing that they mention in 12 factor is no system level subprocesses. What that means is don't use the child process module in Node to execute another executable from the operating system like curl or ImageMagick or DOS2 Unix or whatever it's going to be. This is kind of very a path-specific limitation. And as we move past paths, and we'll talk about sort of containers and what things look like these days, so containers can help with this. The basic idea here is when you're running on a path, you're running on a generic Linux operating system that doesn't have a super broad set of dependencies on it, and you can't really specify the exact versions of things you want, and so forth. So from the path perspective, they're encouraging you to really be a pure Node app. Just have JavaScript that runs in your app and don't fork off any subprocesses because everything's going to break and it's going to be hard to troubleshoot, and they can't really provide that in a reliable way. In the container world, you can do that, and you can say, I want to install ImageMagick at this version and know it's going to be there and work. And so just keep that in mind, that this is a little bit dubious, and there's a anti-pattern called the inter-platform effect, where every new platform of software has to re-implement the entire world of functionality just because to keep it all like 100% pure Java or the equivalent. So ImageMagick exists. It's a great program. It's open source. There's no reason you should try to like write low-level image manipulation in JavaScript when you can just fork off an ImageMagick process and make some thumbnails. So at the high level, like this is kind of a limitation of paths that doesn't seem smart in the long run, but there's good reason why they're making this recommendation. I mean, the other thing is, if you're using curl and you're making outgoing HTTP requests, the implementation in curl is so much better than the implementation in your brand new scripting language that just came out last year. It's like beyond belief. So if you tried to use Python, URL lib for the first 12 years or so, like it just wasn't even close. Like curl actually works. Python URL lib doesn't handle any tiny variation. Oh, there's a proxy, I'm dead. Oh, they sent this header, I'm dead. Oh, they sent this other header, I'm dead. So, I mean, HTTP is particularly complicated, but just keep that in mind that, like, especially in PHP, you see people using libcurl all the time, and it's like, great, because libcurl is correct, and if you're trying to use something else or you're trying to hand code something, it's not going to work. It's going to fail. And it took a long time for the HTTP module in Node to actually be reliable enough that you would use it instead of curl and want to actually get your responses and not, get a partial error message or don't handle pipelining or don't handle chunked encoding or, all the complexities of HTTP. So that's why I'm sort of want to make sure you take this with a grain of salt, that yes, it's great when your app can just be deployed on a path, but that doesn't mean you want to rewrite, image thumbnailing or whatever of the wonderful world of open source software is out there available for you. Okay, third is configuration. This is another one like Codebase that's like, it's so easy to get this right, but people get it wrong all the time. And I don't really know what the motivation is to do it wrong, but they're out there and they're doing it. So the 12-factor app is very clear about this because this was probably one of the biggest messes that they were dealing with, I think, initially. And they say that a 12-factor app gets its configuration from the OS environment variables. End of story. So you cannot read any files off disk. you cannot make HTTP requests to load your configuration or anything along those lines. It's like whatever you need should come in through environment variables, and then you're off and running. And I'll show you how to do this in the PaaS environment as well as outside of PaaS environments. Again, like a 12-factor app, you could decide I want my apps in my company to be 12-factor, and you could deploy them on your own servers without a PaaS, and that would still be valid. So I'll show you what some of these look like. The other thing is don't use this Rails notion of named environments where your environment is called production or development or staging. It's a terrible anti-pattern. It couples everything in bad ways, and you want your staging to be running in quote-unquote production. Yeah, so that's one thing that there's lots of modules on NPM that encourage you to do that took that pattern from Rails and adopted it, but don't do that. If you want to have PayPal sandbox, just say, the PayPal API URL is sandbox.paypal.com. Don't say, oh, because the Node environment is staging, I'm going to use this PayPal sandbox API URL. Not easily. But that might just be my keyboard layout. Yeah, hang on a second. Let's see if this works. Okay. So don't do that. I recommend the npm module config3, which I wrote because I looked at about 100 of the ones that were on there, and they were all either poisoned by Rails production staging, or they used YAML, which I think is completely a sin for Node and JavaScript, or they were just like super complicated and tried to read your configuration by mind reading and sending a text message to your iPhone and all this kind of stuff. So I recommend config3. It's really simple, and it's clear where your data comes from. But there are lots of good modules for that. So that's configuration. Number 4 is backing services. And the idea is to treat these as loosely coupled. And by backing services, they basically mean your database or anything else that acts like your database, whether it's S3, however you send emails, whatever you might ship events off to, any kind of external services that you integrate into your application. Use your configuration parameters to connect to these. That's what URLs are for. Try to use URLs for this. And the idea in the 12-factor app is just by changing your configuration, they should be able to point your app to a different database, for example. So they could point to a database that's on another Heroku system or on an Amazon RDS or whatever, and your code should not have to change. You should not have to do another build and deploy. Unfortunately, when it comes to databases, most Node database libraries do not actually make this that easy to do properly. They don't make it easy to detect when your database is down and your connection is not working and reconnect properly. It's sort of just the state of the world as it is, nor are they very standard about how you specify your configuration information. So it's a little bit sad, but it's gradually getting better. Again, this is another thing that it's much easier to do it right than do it wrong. But some people still do it wrong. So number 5 is build, release, run. And this one I see done wrong all the time. But the basic idea is your life cycle should have a distinct event, which is called a build. And the idea of the build is get the source code and run some processing on it that produces a build artifact. And Heroku calls that a slug. For open source software forever, this is what the make command did. And it's a little confusing in Node because it's a scripting language, so you don't technically need to compile it. Obviously, if you're a C developer, you can't imagine not having a build phase because that's what you've done since day one. You start with source code and you produce something executable. With Node, it's a little ambiguous because technically you can actually just write a single JavaScript file and then run it and you're good to go. But it's good to have an actual build step. And then release in the 12-factor terms is combining a completely generic build artifact with a specific set of configuration values. That means, okay, this is going to run in production. We're going to use this PayPal API. We're going to use this Amazon API key. All of your usernames and passwords and API keys and configuration values that you need, when combined with a build, that creates what they call a release. And then run is taking that release, putting it on a server, and firing it up. So the difference between a build and release, if you're using config3, it could be just the presence or absence of an additional config.js file that is, okay, these are the values we use in staging, or these are the values we use in production. What else do I want to say about this? So the most common anti-pattern I see in the Node world is there is no build stage. And actually, Heroku and Path sort of makes it easy because they hide the build phase from you. Their sort of marketing message is you do a git push and then your app is running. But what's actually happening behind the scenes is they're doing a build as a distinct phase. They create this thing called a slug, and then they combine that to create a release. And the sort of release values you can edit in your Heroku web app and set, this is my database URL, this is my user, my password, my port or whatever, my concurrency settings. They combine those and then they run however many dynos you have allocated for your app. But from the developer's perspective, you run one command and then it's running. So don't be fooled by that. If you're not using Heroku, you want to have an actual build process. And I see a lot of situations where you push to master and then someone SSHs into production, does a git pull, git fetch, and then starts doing a bunch of stuff like on the production server, which is like terrible. So it's like that kind of build stuff is extremely fragile, and you don't want to do that on the server that's running. You want to do that on a different environment where those failures don't impact your users. And stuff fails all the time. And particularly most times in a build, if you're using NPM, you have to go to the internet and download a bunch of software and run a bunch of post-install scripts that are all kind of fragile and clone some stuff from Git. And that stuff takes time and it's slow. And it produces a big artifact that's can be tens of megabytes, hundreds of megabytes. So you definitely want to get that done and have a distinct file that you can rely on and say, if I take this file and put it on my server, it's going to start up. So don't do build on your production server. What else here? The other thing is that because of the way NPM works and because shrink wrap isn't really reliable, if you were to actually do a rolling deploy on production servers, if people are publishing new versions of NPM packages while you're doing that, and given that there's 140,000 packages on NPM, chances are Substack has published 6 new packages by the time your deploy finishes. All your servers won't actually get the same software. That's just because of how Semver works and so forth. So servers 1, 2, and 3 are running _1.18, and then servers 4, 5, and 6 are running _1.19. And you don't want that. So that's why you do your build once and say, whatever was good when we did the build, all the servers are getting that. That's another thing that I guess it's very common for Node developers not to realize that that can actually happen. Let's see. Yeah, and the idea of git pull and npm install in production is actually fairly commonly espoused by junior developers who don't have any operational experience, but just ignore them. It's a terrible idea. For reference, put that advice in the same category as people who advise you to SSH into a server and live edit some PHP files and then just save them and exit. Don't do that. Yeah. Okay, so processes, this is factor 6. The idea here is your application can have a bunch of processes that are doing work on behalf of the system. If you are not using a PaaS, you can use the process supervisor that the operating system provides, which is what I recommend. So the new one is called systemd for Linux, and it is very easy to create a systemd file that will properly supervise your application. So if we had an app called my Node.js app, we could create a file at etc systemd system, my Node.js app.service. This is the entire file. It's very straightforward. You give your application a description. You run it as a user and group, which are not root. So you have a non-privileged user there. You give it a working directory. And a great thing you can do is give it an environment file where you can load your configuration. And systemd will read that file, parse it as key equals value new line, and make that available as the environment that your application is running. And then you say node my app. Hopefully you're using a cluster, so you can start the cluster, and then restart equals always means you get process supervision, and that's it. And this last line is kind of boilerplate. It just means start the thing when the server boots. So it's not very difficult, and this doesn't change that much for different Node apps. This is kind of the one. And so forget about Foreman and PM2 and any kind of like node-specific process supervisor. Just use the OS. It works great. Prior to systemd, if you were in the Debian Ubuntu ecosystem, there was this thing called Upstart, which I actually like more than systemd, but systemd sort of is the new thing. But it's a very same thing. You put this file etc init my Node.js app.conf, and you can see it's the same thing. This is my user. This is my directory. This is my environment. This is the command execute app server.js, and that's it. So both of these will handle keeping your application running. They'll handle managing your log files, rotating them out, and system administrators will automatically know how to manage your application because it's the standard start, stop, restart commands that all of your operating system services use. So these are both really easy to do if you're running on your own servers. Yep.
Yeah, just quickly, where you have like the environmental variable node environment production.
Yep.
How is that going to be interacted with differently than what you were talking about against a couple of slides ago? But, you don't want development production. Obviously, you need those differentiations. How is this going to be in the real world differentiated from how most people use, development, testing, and production variables?
Right. Okay. So the question is for the recording, we're setting node-end equals production, and how is that going to be used in this app? So I set that because unfortunately in Node, the express module actually looks at it directly, which is why it's a terrible anti-pattern, and enables caching and a few things along those lines, or at least it used to. I don't know if they still do anymore, but at one point there was a few important modules in the NPM ecosystem that would actually behave differently if node-end was production or not. But those were third-party modules that I didn't control. So I just set production everywhere on staging. If I have stage, test, anything that's production-like, I always set the environment production just to make sure anything in the NPM ecosystem that looks at it assumes, OK, production. Because I don't want to have staging, have caching turned off, and have crap performance, and then get to production and have things be wildly different. So that's kind of why I said that, but my code doesn't look at that at all, for the most part. I do, once in a while, I do a few things looking at it, but the idea is if you want to configure a particular thing about your application, you should have a specific value that controls that behavior and not group them all into this big coupled bundle. But that's a good question. Yep.
Would you mind going back to the previous slide just
Yep.
for a sec? Just want to steal something.
Yeah, so this is systemd, and all this is available, again, on the website. You hit the down arrow to get the details. But they both work fine. And
I'm interested in your cluster.js file, because you mentioned that you don't want to use PM2 or whatever, and I think that's really the main reason why most people use cluster. But it seems like you're doing all of that with your cluster.js, yes?
yeah, so usually Node is single-threaded by default, and if you just start an Express server, you're only going to be able to use one of your CPU cores. So most of the time, but the reality is if you don't have a lot of traffic, that's actually fine. But it's a good habit if you're going to have high traffic that you want to use the cluster module so that you can take advantage of multi-core hardware. And in Node, you need about 30 lines of boilerplate to do this. So I usually just have that boilerplate. There are helper modules, including one called Throng that Hunter Loftus from Heroku has written. But they basically see how many CPU cores you have and spawn one worker per CPU core. And the way it works in Node is the Node process will listen for connections on a particular TCP port, could be HTTP or not, and it will farm those requests out to worker processes. But the boilerplate you need, and basically the idea is if one of them crashes, it'll log that crash and start another one. And so there's not that much to it. So I usually have those little 30 lines of boilerplate. And if you just go to the cluster documentation, the main Node doc, like the boilerplate is right there. It's not a big secret. So that's typically what I end up having is a separate file that is cluster that's not really coupled to my application. It'll just require the server.js file that has my Express application. But the cluster one just does that in production so that there's a bunch of them running. And normally when I'm developing locally, I'll just run server.js and just have a single worker. Does that make sense? Okay, other notes. So yeah, don't run as root. That's also fairly common in the Node world. It's a big security risk. Node is not, JavaScript and Node in general are not particularly super hardened things. So if it's pretty easy for an attacker to execute arbitrary code as root on your system, they're going to trash you. So don't do it just because it's convenient. The other thing for 12 factors is don't daemonize. So 12-factor apps stay in the foreground, which is, again, it's the easier thing to do, and it works better, so don't daemonize. And we went over the rest of the stuff. The other thing they point out in 12-factor is you can use the local file system, but you have to use it in a smart way, only for temporary files, only for an atomic operation that can either succeed or fail. And if it doesn't get all the way through and that dyno suddenly disappears, you have to code your application to handle that. So that's processes. Port binding. This is, again, not so much for Node apps, but other apps that we're running on Heroku. This is sort of so obvious it's hard to explain, but you should listen on a network port and provide a service, as opposed to I watch this directory on the file system and I magically do stuff when files show up. Or, I don't know what you would do other than that on the internet, but bind to a port and provide a service there, and that's how you talk to clients and do work. And most Node apps, they do this, so this is not really a problem. The only other thing is for web apps, very often you need to know what your fully qualified domain name is, your absolute URL, if you're going to send out emails or that kind of thing. You can get that from your config, from the environment variables, if you need that, which is, when the apps I build, it's very common for me to need to know what the sort of vanity domain name is, so I can, mostly for sending out emails that have the right URL and that kind of thing. Okay, factor 8 is concurrency, and basically the idea is scale out. Like I said, there are businesses where scale up makes sense, and even you can see posts from the 37 Signals guys where they're like, we scale our databases up, and we're happy. But for PaaS and for 12-factor, they want to be able to create capacity by spawning more and more dynos, and distribute the compute load and the sort of networking I/O load that way. Let me just catch up on my notes here. The other thing is design your app with distinct worker processes type. So if you, for most apps, when you get started, there's just one thing, which is the app server. But as you get into background jobs and having a bunch of stuff that's processing beyond your user-facing application or your API that you're serving, Each one of those should become a worker type, and you can spawn up dynos doing that. And then the other thing that Heroku mentioned to me is they see local state, whether it's in-memory state or stuff that's on the file system, is another super common anti-pattern that causes applications to fail to scale out. So if you have a any kind of shared queue or work queue or a bunch of state that you're just keeping in memory in Node, and that's supposed to be global for your whole application, like, have we seen this user before or not? That doesn't work when you start scaling out. That needs to be shared in an attached database so that all of the workers have a common view of that. And same thing if you're using the file system and trying to, people are uploading avatars and you're just saving them to the file system. If I upload an avatar and it hits server 7 and then my mom logs into server 6 and tries to see it, it's not there. Once you've actually built an app that has more than one app server, this stuff is all kind of fairly obvious. But if it's your first app, it's really easy to not realize, like, oh, that server has a different file system that has other files, and they don't magically sync. So that's the main thing there, is like, just make sure you design for scale out. Number 9 is disposability, which basically means any node should be able to be suddenly disposed of, either intentionally or as just a matter of course, without causing a major problem. What did I have here? And sort of the implication there is using robust queues for any kind of long-running job that needs a bunch of different steps. Put it in a queue so that you can get step 1 of 7 done, and then have that node die, and another node will pick up with step 2, and not abandon it and not repeat step 1. Again, that kind of thing. And I'm sure, like, each of these things that got into the 12 factors came from at least 1,000 support tickets at Heroku where people had violated one of these principles, and they're like, stop doing that. Number 10 is dev prod parity. This is another one I see almost all the time in my consulting work. You really want dev prod parity, or at least stage prod parity. And this one in 12 factor, they talk a lot about, especially in the Rails, earlier days of Rails, people would use like SQLite or these lighter versions of their backing services for development, and then just trust that when it got to real Postgres in production, it would work the same. And so Heroku is saying, don't do that. Use whatever you use in production, use in dev as much as possible. And in my mind, this is the kind of thing that can avoid a whole class of problems, and it's relatively straightforward, so just do it. Especially these days, we've got Vagrant and we've got Docker, and those two things together make it really easy to, if your production stack is CentOS 7 running Postgres, 9.3.7, then get yourself a Vagrant box running that exact same configuration and talk to that from your local development environment. So if you haven't tried Vagrant, that is a really handy tool for this kind of thing. And then the new player is Docker, and that is also really cool, where especially with the consulting work I do, I switch to lots of different clients. Each client has a different stack, so it's really easy for me to say, oh, client 4 wants help with Redis 2.4.6, and I run one command, and then I wait a minute, and there's a Redis 2.4.6 server running, and then once I'm done with it, it goes away. So this is actually fairly straightforward, and the tools are pretty good these days, so go ahead and use them. And my local setup now is I'll run my Node app on my OS X machine directly, and I have a boot2 Docker machine that is running courtesy of Vagrant and VirtualBox. And then in there I can run containers for whatever databases I need. And I can run the exact version that I want to run in prod. And that works pretty well. Okay, number 11 is logging. Let me just see how we're doing on time. Did I skip 10? Nope. Okay. Okay, so logging, again, this is one that many stacks have gone overboard, and I think from the 12-factor perspective, they were like, okay, this is nuts, we're going to simplify. So the 12-factor rule for logs is your application will write logs to standard output. End of discussion. You will not write to the file system, you will not rotate logs, and ideally, they're in a format that is primarily machine readable, but also human readable-ish. So I recommend new line delimited JSON for JavaScript apps, and a lot of other apps are using that. That's a pretty good balance. But the idea is, you should have a standard format, and you want to be able to use those logs in after the fact, and you want to be able to run analysis on them and get intelligence out of them. And if they're just random emails to yourself from the code, it's hard to reason about what's going on to your application over a long period of time. So it's like, do the easy thing and everyone will be happy. The modules I recommend, there's a lot of good modules on NPM. My favorite is called Bole, B-O-L-E, by Rod Vag, which is the smallest, simplest one. But there's one called Bunyan by Joyent, which is also excellent. And there's another one called Winston by the Nojitsu guys. Both of those, they all write new line delimited JSON to standard output. Many of them have a bunch of other features you don't need, but all the basics are there. And there are good tools in the ecosystem to deal with everything else. Storing them to disk, rotating them, shoving them off to a central system for processing in Splunk or Elk, but let the environment handle that. The basic idea is that functionality is the same for every application, more or less, so let it be standard, and don't put it into your application, and don't create a unicorn with special needs about logging. And that's sort of the overarching principle of all of this is like, anything that's really specific to your application, put in your application, spend your time doing that, and everything that really your app should be the same as everybody else's app, don't do that in your app, and use standard tools for that, use open source for that, use commercial platforms for that. And that's sort of where you'll get a good bang for your buck. Just like you're probably not going to write your own email distribution system when you can sign up for one of a dozen really great services. Anything like that, if there's commercial offerings out there or there's an open source thing that does it, and there's no really compelling reason why that won't work for you, then use that. Other things in logging, so systemd and journald will do all this automatically. Same thing with Upstart. So it will capture your logs, it will write them to disk, it will rotate them for you, it will gzip them after they're rotated. It's all standard. So you don't have to do anything special there. Just learn Upstart or systemd, learn how they use it. And then with the new systemd, there's a whole separate component called journald that is responsible for managing logs, both from your application, but from the kernel and everything else running on your box. And it has query capabilities and filtering and all kinds of fun stuff. So you can do that. If you don't have those available, there are also two old Unix tools I want to mention. One is called svlogd from a suite of tools called Runit, and the other one is called Multilog from a suite of tools called Daemon tools. Both of those are open source Unix programs that you can just pipe standard input to, and they will handle logging for you. And they've been around forever and are battle tested, and they use crazy stuff. They've got 64-bit timestamps because there are applications that are running with a throughput of logging that's so high that they've got 1,000 messages every millisecond, and they can't tell them apart.
What are those two tools called again?
svlogd, and again, all this stuff is in the secret notes that I'm trying not to have you guys look at the screen too much. But so svlogd is the particular program. The whole suite is called Runit. So if you do yum install Runit or apt-get install Runit, you'll get this guy. And then Multilog is this suite of things called Daemon tools by Daniel Bernstein. And if you don't know him, look him up. He's a crazy famous programmer with lots of cool, really cool software, and he's just very interesting. So Multilog is from his suite of how to write POSIX programs. And it also is this crazy things where like under no circumstances will it lose a single byte of logging ever, and I tested it and I proved it, that kind of stuff. Okay, 12 is admin processes. So what are admin processes? This is anything that you have to do like on an ad hoc basis that that is not something that happens on a periodic basis that you build into your application, but just once in a while we have to run this like report by hand, or the CEO asks us to like run this report or send this email, or like, oops, something went wrong with an email, we need to resend one. That's what this is, and this is kind of a tricky thing. If your app is up in the cloud running on a cluster, it's like, well, how do I do this? The basic idea is stick them in a bin directory, make them accessible from the command line, and the 12-factor, the main message in 12-factor here is like, these things should use the same code that your application is using, the exact same version from the same files, just to have that consistency so that you don't run this thing and realize you're actually running an old version of the code and everything's different now and everything goes haywire. So what I do is I just create a bin directory, and whatever scripts I need, I stick them in there, and I make sure that they load my Node modules and whatever code I need from the application that's in the sibling directory. And after I get through this, we'll go through some examples I'll show you there. But that's pretty straightforward. So that's the end of the 12 factors that we've gone through. I'll also show you the site. So this is the site, if you haven't looked at it, 12factor.net. You can go through and read these. I've sort of summarized them all for you, but it's a very concise site, and it's you can read it in 15-ish minutes. So it's definitely worth reading through this at least once. And this is something that I revisit periodically. I mean, obviously, I think it's important and it's valuable. So I've gone through every year or every 6 months and sort of revisited and rethought about it. Does this really make sense? And is this something that is really a bunch of wisdom, or is this like something that Heroku put in because they couldn't get it to work otherwise? Anyway, so that's the 12 factors. Any questions so far on those ones we went through?
System D versus Upstart and something like some monitoring type software. Like Upstart is, I feel like it's been around a long time,
Yep.
tested. System D feels like a new kid.
Yep.
What are just your thoughts on Upstart versus System D?
Okay, so the question is basically, what are your thoughts on Upstart versus System D? I'm not an expert on either of these, but the basic idea was, the brief history is Unix init systems have been around forever, and the one that lasted for like 20 years, it was called System 5, and that sort of was this is how you boot Unix systems forever. And it had a lot of simplicity and it had a lot of power, but I don't know exactly when. Let's say in the mid-2000s, late 2000s at some point, the limitations of it started to become a real problem. And basically, it was so simple that it was really reliable and easy to troubleshoot, but everything was done in series. There was no way to really specify dependencies between, this app requires this database, so start this database first. And it was all done with naming conventions with alphanumeric ASCII order. Service 10 starts before service 11, starts before service 12. And it had some limitations. So after about 20 years of being good enough, people started to say, this is no longer good enough. And especially with laptops and people plugging in USB hard drives, and a lot of the systems becoming a lot more dynamic about what resources were available, they said, we can't have this thing that just runs when the computer boots and like mounts the file systems and then it's done. We need something that is event-based, and we need to express dependencies that this service requires the network. And when the network goes down, stop this service. But when the network comes back up, start this service. So that's where both Upstart and System D that's the technical reason why people went in and rewrote these. And as far as I know, Upstart came out of Debian, and that was the Debian solution to this. How are we going to deal with USB things getting unplugged and plugged, and the network going in and out, and all these sort of laptop-y things, and just generally expressing dependencies. And so the upstart config file so you say start on file system and started networking is basically a way of expressing dependencies, saying like, this application needs the file system and it needs the network. And once those are both up, you can start this application. And if those go down, you should stop this application and restart it when they come back up. Which is something the old System 5 init could not do. It was just like, I started it when the thing booted. You're on your own. SSH in and restart it if it stops. Now, this came out of the Debian project as far as I know and was only really adopted by Debian. Again, I'm not really an expert on this, so some of this could be wrong. But it has a lot of the same features as systemd. It has dependency. It has concurrency. So you have this dependency graph, and things can run in parallel. And that's kind of why laptop boot time started getting faster, was they rewrote the init such that you could, be counting the CD-ROM drives and looking at the disk and figuring out what resolution the display was all at the same time, starting a bunch of databases at the same time, and just letting the system deliver the I/O to those things as fast as possible and let things run in parallel. So that's sort of why I think it came into being. And I'm not really sure why systemd got written, but basically there's this one developer, Leonard Pettering, who's the lead on systemd, and he sort of has a very strong personality like Linus. But anyway, he wrote this other thing called systemd, which is very different from System 5 init. It has dependencies, it has parallelism, and it's quite monolithic, and it's sort of like an all or nothing. And there's been a big debate in the Linux community, is this a good thing or a bad thing? So you can see like there's websites that like systemdsucks.net or whatever. There's a community in the Linux world that thinks systemd is a bad idea, but in general, the major distributions have all agreed we are switching to systemd. And so now Debian and Ubuntu have decided we're switching to systemd in the current release, and we are going to continue to support Upstart for a while, but long-term systemd has sort of been the one that people are going with. I just started working with systemd recently, and it was a struggle because there's no good documentation that I found. Actually, the best documentation I found was a systemd for Upstart users guide on the Ubuntu wiki. So systemd is a collection of like 12 independent programs, all of which on the homepage talk about the low-level Unix signals they use to communicate with each other, without any description of like, what is the purpose of this program? What does it do? How do I tell if it's installed? How do I run it? So it took me forever just to find out, if I want to put a service into systemd, what file do I create? Where does it go? What goes in there? How do I know what the valid values are? And so it's all these like man pages that are like encyclopedia length that talk about every possible option without any complete example. So it was a struggle, but once I got it, it's like, once you have this one, it's like, just use this. But you can go read the man page for like a very obscure thing, which is like unit.service, and there's all this terminology, and they'll tell you what the valid sections are, and what the valid keys are, and what the valid values are, and whether you can have more than one, and blah, blah, blah. But it's a little bit of a struggle because there's no, as far as I could tell just from Google searching, there's no like, here's a comprehensive introduction to systemd and how it works, partially because it's reused by all the distributions, so none of the distributions want to document it because it's not really their project. So no one has really taken ownership and said like, here's the real guide for humans.
If you are interested, Arch Linux has the best one I found.
Okay, so apparently Arch Linux has a good set of documentation.
DigitalOcean has like a really good one as well for systemd that I've followed.
Okay, and DigitalOcean also. Yeah, in general, I find that DigitalOcean, like blog and tutorials are really, really high quality.
I got one follow-up. So you said they're going to only support Upstart for so much. Do you know how long that is?
I don't, probably essentially forever. I mean, because we still have System 5 programs that were written in 1984 that basically run unchanged. So I wouldn't worry about it. Yeah, I mean, in general, the Unix, Linux people tend to support stuff like way longer than makes sense for any reason. So, Linux, you can see quotes from Linus Torvalds saying like, I want this binary that was compiled in 1995, like to run unmodified today. And all the developers are like, oh, if we could like just deprecate this one thing, like we could fix this whole subsystem. He's like, no, binary compatibility. So I wouldn't worry about it. A while, probably. Okay, so that's sort of 12-factor apps, and again, that's sort of all wrapped up in platform as a service, but I wanted to take you guys through some other trends that are happening, some of which are newer than platform as a service. One of which is called immutable infrastructure. This is the idea that the only ways, the entire life cycle of servers is they are provisioned from scratch, they operate, and then they are terminated. And at no point does anyone SSH in and modify them in any way. And if you want to change them, you adjust the code that provisions them. You provision different ones. You add those to your load balancer, and you deprovision the other ones. And you can see some, if you Google this, you'll see articles. Chad Fowler from Wunderlist and from the Rails community is a big proponent of this. So a lot of people are just seeing that this idea of SSHing in or using configuration management tools to go in and make changes to existing servers, some of them are just like, you know what, this is a losing battle. I don't want to deal with this. I don't want the risks that come with it. If you can't bring up a server that's ready to go, then it's not production ready. And the other really good sort of analogy that has been made is the idea of thinking about your servers as pets versus thinking about them as cattle. The idea is the old days, servers were pets. They had a name, they had a personality, and you cared for them. When they got sick, you nursed them back to health. You wanted them to live as long as possible. And that's sort of the old pets model. And the newer cattle model is you have a bunch of these things. They don't have names. They have numbers. And your concern is that you have enough of them that are healthy overall. And when one gets sick, you shoot it in the head, and you bring up another one to replace it.
Pretty sure there's someone here that's going to get pissed off by that.
Yeah. So I didn't invent that. I think that originally came from Randy Bias. I have a few links here. Oh yeah. So it's been around for a while, but I think it's instructive to think about it that way. And it's sort of it's just sort of a mindset shift. So there's some links here to where the pets versus cattle thing came from, and the idea of sort of immutable infrastructure. The other thing I just wanted to touch on was thinking about the merits of a commercial service. And I guess this is something I do a lot. I consider it my job when I work with businesses and I work with a CEO or I work with a non-technical founder of a startup to make a good decision about, should I use a commercial service for this or should I build something in-house? So there are commercial services out there that are hands down worth their weight in gold, and you're insane not to use them. And then some of them, I feel there's a lot of companies that enter this market that are basically just a long-term tax on a little bit of learning. And they're like, oh, you're a junior developer. You don't know how to install Postgres. So pay me $20 a month for the rest of your life because I'll install it for you. But at the end of so some of them sort of have this expertise or this capability in the product that really is valuable, and they can really do it better than you can in terms of security or reliability or performance or whatever it is. There are certain things that are like, to really performance tune this is a full-time job, and we don't have that, so we're going to pay this company. And then there's a whole bunch of them that are like, I don't want to read a one-page website about how to install Redis. I want to pay you $20 a month forever to do it. At least that's my take on some of these. So you should try to decide, is this one of these companies that is literally going to run apt-get install Redis for me and then point me at it and that's it. And if so, maybe I should learn how to do that and get comfortable enough so I can just do that and manage it myself. But like I said, some of them are really, really doing a lot behind the scenes, and some of them are really not. Yep.
I'd be interested to hear a couple of each, in your opinion.
So I think, well, I think any email platform is doing a lot, and I would not want to try to keep my outgoing emails out of spam filters, both outgoing and incoming. So, and there's quite a few of them, and they do different levels of things. So I think SendGrid and Mailgun are doing quite a lot. Amazon SES is doing the major things you need, but they're not providing a lot of value on top of that. They're much more like fire and forget. Yeah, your message will probably be delivered, but that's it. And then a lot of them have like a whole suite of admin dashboards and stuff you can look at. I generally find like the managed database services, those are the ones that I always question. Like, if I type yum install Postgres, like, are you doing anything that's so much better than that I really need to pay you for that? Can I just pay you to, are you going to do a database backup for me? And do I want that to go over the internet? And am I going to be able to restore it properly? So I tend to shy away from like managed databases. I tend to shy away from application performance monitoring, just because I just feel like if you don't have a good handle on your application performance, I feel like if you try to use a commercial service to solve it, you're avoiding the problem instead of tackling the problem head on, which is like, I don't know what the hell's going on in my application. And some things are nice, if they give you a flame graph and that flame graph saves you a ton of debugging, then it's worth it. But a lot of them market themselves as like, oh, you don't need to understand your application. You can write whatever and we'll like figure it out and give you a graph and tell you like, yeah, your application is crap. But what good does that do? If you wrote it crappy in the first place and you have no idea, are you going to be able to fix it? Probably not. So I guess that's a few examples. Let's see. Yeah, so my general thought is some of these are like, if you're really a beginner, then they're valuable. But if you're really an expert, they work less well than something that an expert has really configured or is using properly. So, and it just depends. I see a lot of big companies like using MailChimp, and it's like you can tell their mails come from MailChimp. It's like, okay, that's fine. But I don't see a lot of companies like outsourcing their database. Like a lot of successful technology-based companies that are like, oh, we don't run our own database. Like, I don't know, it's on EC2 somewhere or something, So it sort of depends on like how core is it to your business and how important it is, whether you have the expertise, and that kind of stuff. Okay, so we're running a little bit long on time, but I want to take you through. So I have a sample app that I think is almost entirely 12-factor compatible. And it runs in Heroku, and it also runs on Docker. And I'm going to quickly take you through it. And it's open source, so you can go ahead and look at it. So these are the 12 factors for those of you with bad short-term memory. So the code base one should not be a surprise where this links to. So there's one repo for the whole app, and it's up on GitHub, and there it is. So no big deal. Dependencies, so where is this going to link to? Package.json, right. So again, not a big surprise for Node, but put your dependencies in there and use package.json. I use, like I said, my config3 module. I'll walk you through this a little bit. Yes. Okay. So I just added Heroku support recently, but the idea here is this line basically gives me Docker compatibility, and the environment variables don't have any sort of standard about what their name should be or what their values, but the way Docker gives you your database is sort of this format, so I can get it from Docker, but Heroku has this thing called database URL. So if that's there, then I parse that out, and then I can connect to a database provided by Heroku. And so this is how config3 works. Basically, you just export an object. And I do a few things like looking at, if I'm in production, but I try to keep it pretty minimal. And basically, the main thing is when I run my tests, I want to turn off logging so I don't get a bazillion things on standard out when I'm running tests. So that's config. Backing services. This is my default, basically the same idea, but this app is a Postgres app. So the only real backing service we have is a Postgres database. We get it from config. So build, release, run. I have a shell script that has some tasks. One of them is build. Because this is a Docker app, primarily when I do my main Docker build, I just say Docker build, and it uses a Docker file and creates the app. So for Docker, there's a Docker file, and it's pretty straightforward. When you deploy to Heroku, they use this thing called a build pack. And for Node, there's one for Node. And that basically amounts to checking out your source code, running npm install -- production with a few variants. They look at your package.json to figure out which version of Node and npm you need, and then they fire up your app. So that's that. So processes. So for a Docker app, this is what I do. It's a little different in Docker, in the world of Docker in terms of processes. So right now, I am so far being successful with just, if you look at line ED2, -- restart equals always. So there's no process supervisor. It's just Docker itself running Node directly. And if it crashes, Docker will restart it. And because of the way Docker works, that is as fast as just starting Node yourself. It's not the same as like booting a VM or starting a dyno. So far this has been adequate for me in the Docker world. And then in Heroku, you get the supervision sort of for free. I believe they use Foreman for that. Yep.
Do you advise doing it that way with a script versus using like Docker Compose?
Well, this app is only one thing really, plus a database. So I don't bother with Docker Compose, but I think Docker Compose is good. And if I had a bunch more different types of nodes, I would probably use that and get more mileage out of it. Right now, it's just like a generic run a Postgres image off the shelf and then run the app. So it's not super complicated.
Docker Compose is really good for orchestration, so if you have a lot of services, getting them to talk to each other.
Yeah, and Michael did a meetup for this meetup a couple weeks ago, months ago on that topic. Let's see. So port bindings, processes. Let's look at this guy. So if any of you are interested in graceful shutdown, I coded that and got that working for this. Zoom out just a little bit. Is that too small? Good enough? So this is the port binding. When you call listen on a port and IP address, that starts up your server. And the other thing I did was code a little graceful shutdown by binding to the sigterm signal. So Heroku will send this to you, or you can use the kill command to send it. So the neat thing is when that happens, if I haven't actually started listening yet, like if someone kills the process really early after it starts, you can just exit. But if the server has actually been created, you can tell it to close, and it will handle any existing connections, make sure they get a response, but it will stop accepting new ones. And once those are all finished, then you can exit. So this is, I guess 15 lines of code or so for graceful shutdown in Express. and it seems to work reasonably well. So that's the sort of port binding and disposability. And I have a little bit of an anti-pattern example here for concurrency because I have a daily email that runs a daily report for me, and because this is a hobby app, I just use set timeout and schedule it within the node process. So this is not something that would scale out properly. So you would get one of these per dyno instead of one of these per day. So this is the kind of thing I would want to push to a database-backed queue of some sort to make sure that it runs just once per day, no matter how many application servers I have. And let's see, dev prod parity. Okay, so this is some more of my Docker secret sauce, but basically, because it's based on Docker, you get a lot of dev prod parity for free. You do need to do a little bit of mucking in here. Docker leaks a little bit onto the underlying OS for volumes and user IDs and a few things. So it's not as clean and lovely a container as all the marketing stuff says. But the idea is I have a user for this application. I do run an Nginx to provide the front end that runs in the Docker host. But at the end of the day, it comes down to a few two instances of Docker run and copying some files over there, cleanly stopping my containers and then starting them. And so with this, I can run this against the staging system that's on a Vagrant on my MacBook, and it'll look exactly like production, and then I can run the same script against production and be good to go. And here's logging. So Boulder, the nice thing about Boulder is it's really straightforward to configure. So I have this module called app-log. I require Boulder. I tell it, okay, log at debug, and here's where you should go. Config.logstream always ends up being either process.standardout, or for test, it's this dev null that just swallows all the logs. And then I just export it. And anyone who wants to do some logging can require app-log and call applog.debug.warning.error. And this is a fairly fancy setup, and it's 9 lines of code. Boulder is also really designed to be able to be required by every module so I have this all sort of centralized because Boulder didn't exist when I first wrote this app, but you can also just directly require Boulder throughout your application, and it knows how to sort of combine everything into a single output stream.
Quick question, do you email logs at a certain level?
No, not in this app. I think that's in general a good idea. So the question was, do I send out email alerts for errors or a certain level of logs? I don't, just because I haven't set it up for this app, but in production, I think Splunk alerts or that kind of thing is good. And in general, you want your application's behavior to be centralized somewhere. Like Splunk is a commercial service you can use, and then Elk is this Elasticsearch, Logstash, and Kibana open source stack that people are using. So you can take your logs, shove them into that, and then run alerts on them that basically say, okay, if the behavior crosses this threshold, send me an email. Or if any message with level error happens, send me an email. So I don't do that. And I have really basic monitoring for free from this site called uptimerobot.com, which basically just loads my home page and maybe a few other pages, and just is your app up or down? And if it goes down, that emails me. But that's all I have for side projects. And as far as I know, Splunk is on the expensive side. So
Yeah, I was going to say, would you recommend a commercial service for that? Or would you? I find Elk a little confusing.
I also find Elk a little confusing, so I don't have a strong recommendation at the moment.
also heard that the next version of Elasticsearch is going to have the alerting, so you won't have to run the entire elk stack. You can just run Elasticsearch,
Oh, nice.
and then you'll get the alerting all for free.
You won't get all the pretty graphs.
You won't get all the pretty graphs as far as I understand, but yeah, you'll have at least, the basics.
Okay, so there's a vote for Loggly and the next version of Elasticsearch.
Just curious, did you not exactly the same thing for logging, but for alerts, like if something shuts down? I've used Slack and its webhooks. Have you used that at all, or what are your thoughts on that?
Okay, so the question is, have I tried using Slack webhooks for alerts? I have not, but
They're easy and good. If
yeah.
someone wants them.
they're easy and
I
good.
didn't know if there's anything bad about them that I haven't.
Not as far as I know. I think in general, like the way the only thing I'm really going to pay attention to is email. So I use Slack, but it's kind of begrudgingly. So if it comes through Slack, I don't know if I would see it right away.
I would add to that wherever you want to eventually send those logs, whether it's email or Slack or any other system that you may be monitoring, it's probably a good idea to centralize where you're configuring that and not dump all that in your app, which I think is to your point, to not configure it in the app, send those logs somewhere, and
Yep.
then at that central location, then stream them out to wherever.
Yeah, I know I did a consulting project where we tried this thing called Bugsnag, which sort of automatically, if your app throws an exception, it sends it to a database and sends alerts. And it's like, it's okay, but that didn't out of the box have, have any grouping of like bursts of alerts. And I was just like, this is your one job is like, don't send me 10,000 emails in a second if something goes wrong. Like, have some grouping and batching on that. And it didn't. And I was just like, the way things work is like someone writes some bad code and then they deploy it. And then every web request triggers it until it's fixed. And it's just like, I just need to know that the code is broken. And once I know it, I don't need to know it's still broken because I haven't fixed it. So,
How bad it actually is.
yeah, so I've just have an aversion to tools if I know that they don't have any intelligence in them about quantity of emails that they send me. I'm just like, 0 is a good quantity. It's better than 10,000,
Yeah, it kind of defeats the purpose of emailing altogether. You're just going to start ignoring them.
Right, right. And I mean, the other thing is like, and this I see a lot in Node, I see it in general, but there's a certain level of confidence you need to have that your application runs. And it's really easy in JavaScript or Node or PHP to have a bug that just crashes your app. But at the same, so the tools aren't that great, and you can go write Haskell or whatever to get around that. But the idea is, you want to get to a point where like that your app functions. So even if it's a new app and you deploy it, maybe you watch the logs while you use the app for a little bit and like make sure there's nothing surprising there, and then like it should be relatively good. So if your app can't stay running for a day, or you see things in the logs and you have no idea what's causing them, like this is a problem. Like you should step back, like turn off a bunch of stuff in your app and like get it to the point where it runs. Like I have some alerts, or I do logging on mJournal, and it sort of depends on how you log things. But like when I go there, like I don't see any errors because they only happen when things go really bad, and Postgres is solid. Like it doesn't go down unexpectedly that often. So if I look at my app, it's like someone logged in, someone saved a thing, someone logged out, and it's like pretty cool. And it's not like, random error 7, restarting thingy. It's if that's happening in your logs, or if your app won't stay running, like you have to fix the source code. All these tools aren't going to help it if you're not like able to write source code that's relatively robust, like as a matter of course. And if that's the case, like you should work on that. So I get to the point where it's like, okay, I have a whole pretty comprehensive suite of unit tests that I can run. I have pretty good code coverage, and I can manually test the app or whatever. But I'm pretty sure that like by the time it gets from passing a unit test to like seeming okay on stage to production, like it's not going to be completely shitting the bed. So that's why I'm not so big on like, oh, I want these like email alerts about that kind of thing. At least, for side projects. Obviously, if you've got a big company, you've got an ops team, like that's what they pay attention to. That's their job. But I do definitely see like people ask me like, oh, can you help us with like monitoring? And I'm like, monitoring is there to give you information. If the information is your app won't stay running for an hour, you have to fix that. You don't need any more monitoring. You need like fix the code so the app stays running, and then if you get the app to run for a few days, like get some monitoring to see why it crashes. But I feel like that's a thing that you only need once you've got the basics, the basic stability there. Admin processes. So this is my daily summary email. So every day this thing emails me with some basic stats about what's going on in the app. And this is a little node trick that I do where if you look at require.main and that's equal to module, that means that someone has directly executed this file as the first file in a node process. That means like they're running it as a script. So if so, then I send out the email. But otherwise it can be required for unit tests or whatever, and it won't do anything. You can just load the functions that it exports and use it as if it was just a library module. But so this is my, that's my daily summary email. And if you look at line 1, it's got a shebang, and I have it marked executable in Git, so I can just run this. So if I want to run this in Heroku, I can just run the path to this file as my command in Heroku, and it will like send out an email. And all the configuration variables and the logging will be the same as my app in this environment.
So I was confused by that. Do you not run that with a cron job?
No, I run it with set timeout. So you could run it with a cron job, but it's so easy in Node to just write a set timeout that that's what I do.
Okay, I was wondering why you're doing that require.main.
Yeah, and that's another thing. It's like cron jobs, they couple you to your OS. They have to be deployed separately. They'll try to run even if you've uninstalled your app. So if for the simple case, I can write a Node thing that executes once a day in a few lines of code. So I just do it. Just keeps it simpler. If I wanted it to be a complicated thing, I would consider a cron job, but I would also consider, there's lots of modules on NPM for doing tasks on a schedule like cron, that if you want to do it the second Tuesday of every month, that kind of thing. So you can look at node cron and whatnot and do that kind of thing. So I would tend to do that just so that, I can run it locally and, just not be coupled to the OS for what I consider not that big of a benefit. Like cron is just not that complicated a service, or not that valuable like a service. So I usually code that in the app, but obviously that only works for like one instance, and you almost immediately have to put it into some kind of database backed work queue. So I just wanted an email how many users my app has. It has 7. And so that's just a quick way to do it. That's all I had. I wanted to thank Hunter Loftus, who is the maintainer of the Heroku Node build pack. So he reviewed this material for me and gave me some good input. And also the Heroku Node build pack is a good module you can go and check out if you want to understand when you do git push Heroku master, what happens. It's open source, and you can see exactly what it does and how it works. And you can fix bugs in it and that kind of thing. Any other questions? Yep.
Yes. For this app specifically, sort of this side app, where are you hosting this at Heroku, or is it like DigitalOcean or AWS?
Oh, both. So, yeah. So, if you want, I will do a quick deploy. But basically, yesterday I Herokuized this app. So it is up at mjournal.herokuapp.com, and it's probably asleep. Let's see if it wakes up. Yep. So it runs fine locally. It runs fine on Heroku, and then the actual production instance is on a DigitalOcean VPS running Docker. And so the build process and deploy, obviously for Heroku, the deploy process is git push Heroku master. That's the great thing about it. The Docker process is, Docker build and Docker push. It's slightly different, but they're basically both trivial in terms of like what you have to do. So this app runs fine in either environment.
So you're using a different environment for pre-pod versus production. Isn't that a insight better?
Well, obviously you wouldn't normally deploy your app on two totally different systems, but I'm just doing it sort of to demonstrate 12-factor. So the DigitalOcean Docker is prod as far as I'm concerned, and my staging environment is Docker based in Vagrant. So that's all the same, but just because this is a 12-factor app talk and I didn't want to write a whole new application just to demonstrate 12-factor, because I knew this was already like 11 and a half factors, I just made it 12-factor compatible and set it up on Heroku. It took me a few tries to figure out their database config and to make sure the app works. But now it actually works there. And if you look at the recent commit history, you'll see 12 commits from yesterday. They're like, Heroku, Heroku. Right. One line changes. But it eventually worked. And so I have some code, like when this thing first connects to the database, I have some bootstrap code that says like, I need a user and I need these tables with this schema, and it tries to auto create all that stuff. And so dealing with that with Heroku was different, like the permissions that basically they give you a user that is an admin and can do all that stuff. But when I'm running in production, I don't want my user to have those permissions. So when I run in production, I have both an admin user credentials and a app credentials. So when it starts up, if the database is empty, it uses the admin credentials to create the database, define the schema, but then it switches to a more limited user to do the regular inserts and deletes that are part of the application. Just so that if I get hacked, people can't just like wipe out the whole database quite so easily. But I had to tweak that a little bit to make it compatible with Heroku and just use the same username for both sets of roles.
And what are you using as your backend as a service for Heroku? They don't have a relational backend.
Yeah, they have Postgres. Yeah, you just click you on Postgres. Yeah. So I don't know what else they have, but they have quite most of the really popular ones, and I believe they're not going to charge me yet. But I was able to get this up and running with their estimated monthly bill of $0 with a Node app and a Postgres database behind it. So as far as I know, like I think in the old days it was a separate service or more expensive or something, but they seem to have built-in Postgres now. It seems okay. More questions?
I got one more. How's Docker and containerization going to affect sort of the 12-factor app? I know it's a really deep question.
Well, so the question is, how is Docker and containers going to affect the 12-factor app? I think the main thing is the rule that you should not use any, you should not fork any sub-processes in your operating system can go away. And I think it's okay. You can use the world of open source software. You should be able to fork sub-processes. So with Docker, you can specify an exact base image with these prerequisite things installed. And if you want wget or ImageMagick or whatever, you can have it there. And so that will be fine. And I guess the way you interact with the file system is just different. Within the Docker world, there's another set of do's and don'ts that make your app Docker friendly. And so you want to be able to document where your app writes data so people can mount the volumes properly. Most of it's around sort of documentation and not using a ton of different directories so that people have to mount 12 different things. And then getting stuff from your environment variables. The same thing. So in past, they're like, we don't want to deal with configuration files, just take everything from the environment. It's sort of the same in Docker. For any image that needs some kind of initialization values, they're like, okay, if you're going to run the Postgres image, set this environment variable to what you want the admin password to be. And then when that image first starts up, it'll create that admin account with that password, but it gets it from the environment. So that's kind of a similar thing. And I think in general, just, yeah, not having to be, you can have a more custom build process, because at the end of the day, with Docker, you ship bits that include the entire operating system, any of your prerequisites, and your app, all its dependencies are all pre-bundled. And you can share those, whereas the PaaS ecosystem is the thing you're sharing is sort of the repo. And that's just source code. And that needs to be rebuilt when it gets onto the PaaS. And so Docker sort of frees you from those limitations.
How about persistence? Docker by nature is ephemeral, and then you have like Postgres, which is supposed to be forever. Like, how are you supposed to really do that without having like a backend as a service there?
Okay, so the question.
Maybe that's beyond the 12-vector app.
Well, so I guess the question is about long-term data storage and these services that are ephemeral. And I guess Docker makes it very easy. When you first start with Docker, I mean, this talk isn't really about Docker, but I think Docker is basically like very important. You should pay attention to it. But when you first start, you're like, oh, I ran this database, and then like I stopped it, and all my data's gone. And they make it really easy to just do that, and you're like, who is using this? This doesn't make any sense. But once you understand how it works, like you're like, okay, the data goes over here, and it survives. But the basic idea is separating of the actual like bits on disk from the processes that access and own that data. So for mjournal, what I do is I just, on the host OS, I have a directory, var local mjournal, which gets mounted for Postgres and for my config files or whatever else I need, my log files. And then the containers have access to that through a volume.
You do that in a different container, though, or are you doing that in the same container as your web process?
A different container. So I have one container for my web process and a separate container that's running the stock Postgres. And that one has a volume, the Postgres container has a volume for its data, and the application server has a volume for its logs and a few other, like, I forget what else I have in there. It's mostly logs, but if it does need any persistent storage, like it can use that. But then the same thing, like I have a script that takes my backups from Postgres, and that just runs inside the Postgres container, does a PG dump, and writes that to the mounted volume, and then I have my rotated database backups available. It took a bit of thinking to get that all right, because Postgres is picky about only running as the Postgres user, and Docker doesn't know about that. But once I got it running, like it works and it makes sense, and you can just use PG dump and PG restore as you normally would. And then you have files on disk on your host that are your backups. Now this wouldn't scale, if I had a 100 node swarm, then I wouldn't be able to use the file system for this. I would definitely need,
Not really good for that yet.
yeah.
Yeah, I had a data volume container, it just went down, and I lost a lot. And it was a bad day.
Yeah, so
Not
it's
bad.
new. It's new.
In that case, I just use RDS. Like,
Yeah, I was
right?
say that's like back in, like with Docker, it's just I don't want to mess with Postgres and I want to abstract that out because it's just I don't want to. Docker is ephemeral. It's like it's meant to be able to bring it up and down, and so like having something that's supposed to be maintained forever, it just doesn't make sense to put in a container.
Right.
I don't have that quite figured out yet.
What I've been doing is, so doing the linking with Docker Compose with volumes locally for development, but then, when it goes out to Elastic Beanstalk, then it's just gonna use the environment variable to point to that RDS instance. So that's been working out pretty good so far. Haven't found any weird edge cases yet. Doesn't mean I won't, but.
Did you have a question? Anybody? All right, thanks very much. I guess we went kind of long. Thanks for sticking around.